Hello guys, this is Agastya Agrawal and now we will proceed with electricity part 2 where we'll get to know about many other things like net ionic charge and how to charge a body, what is electric field, etc. So first let's start with net ionic charge. So before we read all these things, I want to show you a practical example of the same. So now we all know about magnesium oxide, which is MgO. Now, the charge on magnesium is Mg2 plus, whereas the charge on oxygen is O2 minus. So this shows us that magnesium is positively charged, whereas oxygen is negatively charged. Now, how do we know this? How do we know whether an atom, whether an compound, whether an element is positively charged or negatively charged? So, we can know that by looking at the number of electrons and by the number of protons. So, we all know that the electrons is equal to negative, whereas the protons are equal to positive charges. The neutrons in the atom is basically not positive and not negative. It is neutral, which we can say it is no charge at all. So now, if we let's look at the example which I have listed for all of you. Let me clear the screen. So now, if we look at the net ionic charges, we all know that a single atom is neutral until it becomes an ion. We all know about a cation and anion. Cation are the ions which are positively charged, whereas anions are the ions which are negatively charged. So, if we look at this image, so we have sodium and chlorine. Now, sodium, its atomic number is 11 and chlorine's atomic number is 17. Now, if we look at the electronic configuration, we know that it is 2, 8, 1 here, and on the other hand, it is 2, 8, 7. So, we know that an atom wants to get stable. So, here we can see transfer of electron, where this electron is being lost by sodium and it is being gained by chlorine. Hence, this will fill the octet and it will convert it to 2, 8, and here it will convert it to 2, 8, 8. Hence, both the atoms are stable now. So, this is an example of sodium ion and chlorine ion which are forming NaCl, which we know commonly as stable salt. So here, let's read this. An atom of sodium has 11 electrons, protons, and neutrons. Hence, here, in this, we can see that sodium becomes positively charged after losing one electron, whereas chlorine becomes negatively charged after gaining one electron. Net ionic charge means that it is basically how many protons you have and how many electrons you have. For example, if I have 10 protons and I have 11 electrons, this basically means that I am negative one charge because the electrons are more than protons. Whereas on the other hand, I have seven protons and I have maybe five electrons. This suggests that it is positively two charged because here the number of protons are greater than the number of electrons. So I hope that you all understood about what is net ionic charge. So now let's understand electric field. This is really important because it shows us that how electricity is generated and how electric field is applied. So as you can see here in the image, this is somewhat how electric field looks like. Obviously, this is imaginary, and this is the virtual sphere of influence. Electric charges, when kept, creates an overall area around itself where its effect can be felt. This is known as the electric field. Electric field can also be known as the sphere of influence in layman terms, because this uh, every electron, it forms a electric field around it, and it can only affect or influence or exert force on another particle or atom when and when only it is present in the electric field. A charge can only exert force of either attraction or repulsion on another charge when it is in its electric field. So I have another example on the next page which will show you how practically this can be applied. So in this unit we are talking about electric field, but I wanted to give you an example of how magnetic field can also be thought as the same. So for example, in this image you can see that how, firstly, the distance between the iron nail and the horseshoe magnet. So for your information, this is known as horseshoe magnet. We can say that the distance is just 1 meter, and hence the iron nail is getting attracted to the horseshoe magnet. But here in the second image we can see that the distance is 5 meter, and hypothetically let's assume that this horseshoe magnet can only exert force up till 2 meters. Hence, since the distance between the magnet and the iron nail is 5 meters, here we can see that there is no attraction. This suggests us that how the magnetic field is getting affected, and how the force of attraction will only and only be applicable the if the iron nail is in the radius of the influence, or else it will not be impacted. So basically, electric field is also somewhat like this, where we have studied in the previous page that how we have studied that how the sphere of influence, if another particle or another atom is present in the sphere of influence, then and then only we can say that it will exert any force. So for today's session, that's it. And in the next session, we will learn about how different bodies can be charged. So